In this video, we are going to investigate non-linear relations. When you say non-linear relation, it is a relationship between two variables. The variables are the independent and dependent variables that does not follow a straight line when graphed. So non-linear, it must not be a straight line. It must not follow or form a straight line when you are going to graph. So in other words, it must be a curved line when you are going to graph the relation between the two variables. So we also have here curve of best fit. We are going to familiar with curve of best fit. It is a smooth curve drawn to approximate the general path or trend in a scatter plot. So let's proceed to the key concepts. So we have here the definition of independent variable is the one that you control, and the dependent variable is the one that you measure during the trial. So it affected by a change in the independent variable. The dependent is it affects the a change in the independent variable. So here in the figure, you can find or you can locate where is our dependent variable located and where can we find the dependent variable. Always remember that the independent variable is located at the x-axis and the dependent variable uh, uh, the dependent variable is located at the y-axis. So this drawn curved line is what we call the curve of best fit. So in deciding the relation is linear or nonlinear, you're going to look at the pattern of the points in a scatter plot. So this is an example of a scatter plot. And then you're going to draw a line or a curve of best fit that will fit to the or that is suited to generalize the scatter plots on the Cartesian plane or on the graph. We have here a scatter plot shows the relationship between time in 5 years interval and the population of a town. Explain why time was used as the independent variable. So our population is the dependent, time is the independent. So time is considered or used as independent variable because it is the variable that you or that is control. So we can control the time. So you can use 5-year intervals, 2 years intervals, 10 years intervals is up to you. So you can manipulate the time or the variable time. While population, you cannot manipulate the population on that certain time because you cannot hold that you cannot decide on that population. So here you're going to draw the curve of best fit in this shown scatter plot. So as you can see here, I have drawn a red line, and it is my curve of best fit on this scatter plot. So it is slightly curved. So let's have practice. Number 1, which scatter plots could be a model using a curve instead of a line of best fit. So obviously, the best model is the letter B. So this is, it could be a model using a curve of best fit. So you can draw a curved line here going there. So why letter A is considered as a line? So in answering this given problem, which scatter plots could be modeled using curve instead of a line, the answer is B. Okay, as you are going to look at the scatter plots, it form a a curve a curve line starting here and going there up. Now we have number 2. The scatter plot and curve of best fit show a relationship between the diameter of rain collection barrels and the volume of water collected. Is this relation linear or nonlinear? Justify your answer. So we have diameter as our independent variable. The volume is the dependent variable. So as you observe, there is already a line or a curve best of fit. So this line is slightly curved, so it is not a straight line. Therefore, this relation is a non-linear because the scatter plot R is forming a curve of best fit. Now we have number 3. An altimeter is attached to a model rocket before it is launched. The table shows the recorded data from the rocket's flight. So we have here time as seconds, 1 second, 2 seconds, 3, 4, 5, 6, 7 seconds. Also, we have here height in terms of meter. In 1 seconds, it uh it is in 230 meters. In 2 seconds, we have 310 meters and so on. So our task is to make a scatter plot of the data. Then letter B, describe the relation. Letter C, draw a curve of best fit. And D, use your model to predict the height of the rocket after 8 seconds. So here I have already the scatter plot of the data. So in 1 seconds, it is located at 230. Okay. I make an interval of 50 in the dependent variable of height. So in 1 seconds, it launched at 2. The measurement of the model rocket is at the height of 230 meters. 2 seconds is in the 310 meters. And for the 3 seconds, we have 350, 364, 4 seconds, 350 again for 5, and 300 and for 7 seconds. It went down to 220 meters. So we have here, we are already done making the scatter plot. And again, We are done in making a scatter plot of the data. So our A is already checked. So this is our A. So describe the relation. The, the relation of the time and the height. So we have here, it form a curve. Curve line. So I'm gonna draw here. So we have, so this is our curve of best fit. So this orange thing, the one that I highlighted, is the curve of best fit on this scatter plot. Next, use your model to predict the height of the rocket after 8 seconds. So therefore, if in if you're going to base this model or in 8 seconds, the height of the rocket will be uh lower than 220, lower than in 7 seconds. So it must be lower than 220. So around here, I guess 100, between 100 or 150. So this might be the location of the rockets at 8 seconds. Letter C. So draw I. Letter B. Describe the relation. The relation of this plot, a scatter plot, is a non-linear because the relation of time and height forms a curved line.